You can be successful at gas chemistry problem solving if you follow this method in your work. When you see a given problem like this, we're going to follow a method of listing some steps and taking it from the information. The first thing you need to do is make sure you list the given variables and the unknowns. The next thing is to, looking at those variables, decide what equation needs to be used and use that equation, writing it down, unsubstituted. Step 3. Isolate the variable to be found before plugging in any numbers. Before, not plugging in numbers in your equation. What do I mean isolate? Isolate means to use algebra to rearrange the equation so that the variable you're solving for is by itself on one side of the equal sign with the other variables on the other side of that equal sign. The fourth step is to plug the number values in and do the math. The last step is to circle your calculated answer, making sure it has units and that it has been rounded for the right number of significant figures based on the sig figs for the given values in the problem. If you'll follow these 5 steps, you can be successful at solving all the different types of gas chemistry problems that you'll be asked to calculate. Let's work together. Follow these 5 with an example. Our example is the volume of a gas at 99 kilopascals of pressure is 300 milliliters. If the pressure is increased to 188 kilopascals, what is the new volume? We've always said let's circle what we're looking for and underline what we've been given. Using this, we can realize I've got pressure and volume. Those are the 2 variables that are expressed with Boyle's law. List the given variables and unknowns. First of all, we have a pressure, number 1, of 99.0 kilopascals, a volume to start with of 300 milliliters. If the new pressure, that means a second pressure, is 188 kilopascals, what is the new volume? This is what we've been asked to find. Number 1, list the given variables and unknowns. That's what we just did. Number 2, state the equation to be used. I see that I have pressure and volume relationships, and that's from Boyle's law, where we have the relationship that says pressure and volume product in one set of conditions is equivalent to the pressure and volume situation in a different set, as long as the amount and the temperature remains a constant. So step number 3, it's directing us to isolate the variable to be found. Well, that variable to be found was this V2. So what I mean by isolate the variable is let's do some algebra to make V2 be on one side of the equation by itself. The easiest way to do that is divide both sides of the equation by P2. That cancels out the unit P2, and we're left with V2 equals P1 times V1 divided by the pressure for the second set of conditions. This is what step number 3 is asking us to do. Step number 4, plug the values in and do the math. Pressure 1 was 99.0 kilopascals. Volume number 1 was 300 milliliters, divided by pressure number 2, 188 kilopascals, equals my second volume. When I punch that in my calculator, I find that my volume comes out to be 157.9787234. Stop. You know you're not supposed to write down all those decimal places. Let's take a look at how many significant figures have been given here. 99.0 is 3 sig figs. 300.0 has 4 significant figures, and 188 also has 3 significant figures. When we are doing multiplication and division, our rule is to make sure our answer is rounded to the same number of significant figures as our factor with the fewest, which is 3. So we're going to take what the calculator said with all those decimal places, and it's going to round to be 158. And what unit is volume given in? The unit for volume will be the same unit as the other given volume, and that was milliliters. Put a circle around your answer when you know you have calculated and rounded with units for significant figures. Now it's your opportunity to try these 5 problem-solving steps with you being asked, what was the original pressure of 200 milliliters of helium gas if when the volume was increased to 350 milliliters and the pressure is measured as 1.2 atmospheres? What is different in this problem? Instead of using kilopascals, we're going to use atmospheres for our pressure unit, but we're still using milliliters as our volume unit. As long as you understand your answer for pressure will be given in atmospheres this time instead of kilopascals, you can do the problem exactly the same following the 5 problem-solving setup steps. Pause the video, take a moment, work it out for yourself, and then I will show you how to do the answer. No, really. You try first. Yes, I'm waiting for you to really try it. Pause the video. Are you almost finished? Really, do the math first. Good. I'm glad you tried it yourself. You are given a volume in milliliters, another volume in milliliters, and a pressure in atmospheres. Listing my variables. What was the original pressure? That's what I'm being asked to find. Volume number 1 was 200 milliliters. When the volume is increased, volume number 2 was 350 milliliters. And pressure number 2 measured at 1.2 atmospheres. Again, this allows us to use Boyle's law that says the product of one pressure and volume arrangement is equivalent to any other product of pressure and volume, provided our units stay the same. Number 1, we listed the given variables. Number 2, we've stated the equation. Number 3, isolate the variable we want. What variable was that? It was P1. How do we get P1 on a side by itself? Let's divide both sides by V1, and we find that P1 equals P2 times V2 over V number 1. Step number 4. Now you can plug in the values and do the math. P number 2 was 1.2 atmospheres. Volume number 2 was 350 milliliters. Volume number 1, 200 milliliters. Lets me know that when I calculate for the first pressure, I wind up with an answer of 2.1. It's a pressure. My original pressure was the unit atmospheres. So I know that this unit will also be atmospheres. I'm finished and I can circle my answer. And that's how you set up and do each of our gas chemistry calculations with all the different formulas that you'll learn for Boyle's law, Charles' law, combined gas law, and finally the ideal gas law. Good luck. If you want to play me at 1 1/4 speed to move through this faster and skip over the llama picture, you're welcome to do so. Just make sure that you're following these problem-solving steps. Good luck.